It's a somewhat of a role changer, somewhat of a capability enhancer, overall probably growing the number of designers, but you certainly don't see people losing their jobs en masse simply because a company decided to add Quilter to their arsenal.
Nothing I see in the next decade that could shift that. Like, I think the demand for what we do is so high that what you actually want is PCB designers, each of whom are now 10 times faster and 10 times more precise than they used to be, and even more of them to just iterate more, build more, because we just need that much more hardware now.
Hello, everyone, and welcome to the Altium OnTrack Podcast. I'm your host, Zach Peterson. Today, we're talking with Sergiy Nesterenko, founder and CEO of Quilter. For those of you who have been paying attention to AI tools in PCB design, you will probably be familiar with Quilter, and I hope you are all as excited as I am to talk to Sergiy today. Sergiy, thank you so much for being here.
Zach, thank you for having me. Great to be here.
You have a pretty interesting background. So being new guest on the show, if you could, just tell us about your background and how you got started in electronics.
Yeah, sure. Happy to. So I did my undergrad. I triple majored in math, physics, and chemistry, thinking I was going to go into research. Took my shot at industry for a little while. It ended up at SpaceX, kind of in the somewhat early days of Falcon 9, Falcon Heavy. Worked there in the avionics group for about 2014 to 2019 in the EMI and the radiation effects groups. And then shortly after that, kind of decided to tackle one of the problems I struggle with at SpaceX in PCB design in particular, and started Quilter.
For folks who are not familiar with Quilter, if you could, tell us about Quilter.
At Quilter, we focus on making layout faster. So the way we kind of approach this is that we specifically focus on how to help you with effectively choosing the stack up for your board, placing your components, routing them, generating the polygons, and getting it to fab. We approach this by integrating very closely to the existing CAD system. So whether it's Altium or Cadence or any of the others, we're not trying to replace them. We're trying to work nicely with them. And people come to us effectively with a completed schematic, a board outline, some connectors placed, and then they iterate with us until they get a layout they're happy to send to fab, hopefully much more quickly than they could do without us.
Sure, makes a lot of sense. Now, most people who are familiar with Quilter will recognize you guys as an AI company. So if you could tell us a little bit about what Quilter is doing with AI. And I'll preface this by just saying when most people hear AI these days, they automatically think LLM, Claude code, that kind of thing.
Yeah, it's a good question. So, taking that as a starting point, if I'm sure most of the audience have tried asking Claude or ChatGPT about layout questions or to generate a layout and got some good giggles, right? And the implication there is obviously like large language models are not for layout, they're for language. They're for language problems, right? And we fundamentally don't see layout as a language problem. We don't see it as a problem where a language model trained on text should be solving it, right? Layout is a geometry and physics and manufacturing problem, right? Which warrants a totally different approach. So fundamentally, we take a few different stances on this, right? The first thing is that we approach layout by creating our own models for this and not just using off-the-shelf language models because, as I've kind of described, language is insufficient, I think, to solve these problems. The second thing here is that we don't take the approach of what large language models do of like taking examples of human output and recreating. Right? Like a very kind of initial obvious approach might be to take a whole bunch of human designs, show it to a model, ask the model to duplicate what the human would do, and just show it to the user. And we very explicitly don't take that approach. So the approach that we do take is more akin to AlphaGo. So for those of you who are familiar with the space, AlphaGo was this kind of very famous event where DeepMind was able to train a system to play the game of Go against the world champion and to successfully defeat the world champion. And the key insight from how they approached that is that they allowed the algorithm that they used to play the game of Go billions and billions and billions of times and just win or lose. And based on the result of winning or losing, to learn to take the moves that win and avoid the moves that lose. So instead of just saying, here's what a human would do, let's copy it, we treat this more as a constraint optimization problem of here is the schematic, here are all of the layout constraints that you would expect it to fulfill, like things like components being closed, things like, having tight return loops, all these kinds of things. And you win if you've met all of those constraints, right? If you computed that the board will work, and then you train the agent against that system, you train it to win against the physics evaluation, the DRC, rather than just mimicking without knowing why, right? That's kind of how we approach this.
So essentially you're defining like a solution space for optimization, right? And technically anything within this solution space for a given component or net or set of pins or whatever, however you construct those objects, that's considered a valid solution. And then you iterate to the next part. I'm sure the solutions are all interrelated, but regardless, right, you have some algorithm where you basically just run through each part, do the placement, and then do the route. And then that's essentially how you optimize it.
Yeah, the interesting thing here is like very, very naively, right? If you're just starting from scratch and you try to solve this problem, you might literally take like an existing CAD system, right? You might automate some of the actions in it, like, hey, move this component, rotate this component, so on and so forth. And then, when you're routing, you might automate like move up, move right, move up, move right, whatever, move diagonally, so on and so forth. Now, the problem with that is that, and of course, okay, you've generated a layout. If there's some number of steps, it's very likely a bad layout at first until you train. And then maybe you export that, run the DRC, and then like run some sort of more sophisticated simulations for signal integrity, power integrity, so on and so forth. The problem with that naive approach is that you have to take millions of actions exactly correctly to have any chance of having a layout that actually does well. Right? This is practically speaking why this is such a hard problem, that the combinatorial space of PCB design is like far bigger than Go. And the question of did you win is also far more complicated than like counting stones on a board. So the other piece of what we do that most people underestimate, don't know about, is that the majority of our team is actually not just focused on neural networks and training. We're actually focused on how do we build a CAD system in which you can take only kind of the smart, interesting actions rather than all the possible actions, right? Like, how do we represent this in a way that allows you to avoid wasting time? And I'm happy to give some examples here, but there's as much tech going on under the hood in the sort of like CAD geometry, CUDA kernels, collision engines, classic solvers, optimization algorithms, as there is in the kind of like reinforcement learning feedback loop.
So there's quite a few questions there, but one thing I want to ask you first is, you're basically saying that your fundamental approach is not to treat PCB layout as a language problem.
Correct.
And one thing I'm noticing and looking at a lot of the tools in the space is they do want to treat it as a language problem, but in terms of looking at the objects, which may be human readable, that define everything in a PCB layout, right? So like you open up a PCB doc file in ASCII, however you say it, right? That's all human readable. So you can like find where the designator is and its coordinates, and you can go through and parse it, right? And that is, I guess you could say, a type of language for a PCB layout. And so they're looking at it from the perspective of, well, we can manipulate this through code. So now we're just kind of generate what is that language, right? So what do you see as the problem with doing that compared to what you're doing?
Yeah, it's a good question. So I will say that like it is theoretically possible to treat it as a language problem and solve it, right? Like I would not argue that it's completely impossible, right? I would argue that it's just the wrong approach. And the way to think about this is, if you think about neural networks, like one of my, kind of pet peeves is that like even the name neural network obfuscates what that thing actually is, right? So like, let's not just like wave a black magic wand and say, AI, neural network, something happens. Let's distill it, right? All that a neural network is a function. Right? It has some input, has some output, and has some parameters into which you can change the function. And when you train a neural net, you are doing nothing more than regression, right? So if you've ever fit y equals mx plus b to a set of data points, you've trained a simple neural network, right? It's the same exact thing. Now, from your experience in fitting functions to data, you find that your choice of function, your choice of basis, has a huge impact on how hard it is to fit that data. So for example, if I have data that just looks like a straight line and I try to fit a straight line to it, y equals mx plus b, super easy. Basic regression happens instantly. You'll nail it. It'll be perfect.
They do it as homework problems in statistics classes, right?
Exactly.
That's how easy it is.
Exactly. Now, we also know that you can fit an infinite number of polynomials to any function. That's just called the Taylor series, right? So you could fit a polynomial to that straight line data. And like, okay, the polynomial has, in the first term, a linear term, so that wouldn't be too bad, and you don't need the other terms. You can also fit a set of sinusoids to all data. That's just a Fourier transform. But how many frequencies do you have to fit that straight line? Now you need infinitely many of them. So you can use sines and cosines, a Fourier transform to fit a y equals mx plus b line. You totally can. And eventually it'll converge. Just it'll converge after millions and millions and millions of parameters, depending on your domain, versus 2 parameters in y equals mx plus b. So the choice of neural network and the choice of architecture is kind of like your choice of function, right? Are you choosing sines? Are you choosing exponentials? Are you choosing Gaussians? Are you choosing linear lines? So on and so forth. And the right choice that converges efficiently depends on what data you're fitting. I see this as exactly the same, right? Like, can you express the PCB problem as a giant list of text that defines exactly where every component is? Of course, right? Like, especially if you look at like KiCad or Eagle, their formats were well defined ASCII. They were XML or S expressions or whatever, and like for sure a language model can export that. But the number of parameters you need to actually represent and capture everything that happens on a circuit board is just ginormous. And so the kind of training you'd have to do, I think, is inaccessible with all the compute on the planet. Whereas if you pick the right representations, geometries, lines, circles, those sorts of things, and the kinds of models that operate well with them, you have a much better time, much easier time fitting to this. That's kind of how I think about why language problems are the wrong thing for representing geometry.
So it sounds like, in your opinion, the future of all these hardware engineering tasks is really going to get away from pretty much anything text-based because of the complexity in training these models and even representing all of the multiple ways of building a piece of hardware in a text format. I guess I'm maybe you understand what I'm saying. I don't think I'm being too clear, but you kind of get where I'm going.
Yeah, I think, like, for example, like reading a data sheet, I think is an excellent task for an LLM. Like, if you just want to like take a bunch of data sheets and ask it about like what's a part that meets my parameters more closely or something, I would never train a custom model for that. Like, LLMs are excellent at that, right? Like, writing firmware potentially is getting pretty good with LLMs. There's a lot of papers that even show like writing Verilog or writing VHDL is getting pretty good with LLMs. I think those problems make sense. And especially as these labs, which I know they do, start to ingest more and more data and examples of that, I think that will work. But like the physical geometry of a PCB and what outline it has and where does a component go and where do the traces go and the analog of that in the mechanical space and the analog of that in thermal space, yes, I think it will not be language models. I think it will be all the other hundreds and thousands of other types of networks that people are coming up with that just don't get quite as much attention as the language models do.
In terms of what these other, code-based generation of PCB layout, type platforms do, you mentioned that it's probably not going to be possible to train a decent model using all the compute on the planet. That, as someone who does not study the total amount of compute on the planet and compare it to what needs to be done in different AI tasks, that feels like a really bold claim. How do you arrive at that conclusion?
I mean, it's a guess, right?
Okay,
like I'm not going to say that I've done the math and like concluded this for certain, right?
Okay.
I'm speaking purely from intuition of like how difficult of a problem this is, how precise you have to be with everything, the number of free variables, and just frankly a little bit of experience of training different types of models at trying to converge in these kinds of systems, right? It could be wrong. It could just be impractical. It may be possible, and with all the compute of the planet. But I just think that like if you choose the right basis function, the job is much easier. So why struggle with the wrong one?
No, that's fair. I mean, when the tool proves itself, it proves itself, and you might as well, get on the train or get left behind, I guess is kind of my view on it. Yep. So with that being said, there are a lot of strong feelings about AI. I mean, of course, those all center around LLMs, but we're kind of in this AI revolution right now where it's being applied to everything in all sorts of different contexts. And the feelings tend to be very extreme, right? Either it's trash, it's a lying machine is one thing I've seen people say, or people are on the other extreme end, like no one's going to have a job anymore. What will people do with their lives? Everyone's going to be in poverty except for the tech trillionaires, like the real extreme dystopian views. And then there are just kind of the rest of us who are kind of stuck in the middle, who are just like, we just like what we do, and we don't want a tool to totally replace us. So with that being the case, what is your philosophy as somebody who's actually developing this tool? What is your philosophy on what the designer's role is going to be, and what is it possible for the tool to do in order to enable that?
Yeah, I think, one thing I'll start to preface this, because I think we should ground this conversation sort of like not in the infinite future, but sort of like in the next few years for now, right? Just like a kind of a very tangible timeline, which is much easier to predict and much more practicable to action towards for the foreseeable future. I think that one of the things that, kind of a fallacy that I see common, just when people discussing different AI tools on the internet, is that people will talk to ChatGPT or to Claude and even watch it code and get the perception that like, hey, this thing is so smart, right? Like it's like really able to solve these complicated problems and like really do this thing that's like impressive. Okay, all of AI must be generally that intelligent at everything else. And that's actually a massive leap that I totally disagree with, right? I think it's like we live in a world of very specialized AIs. We lived in a world where if a giant lab focuses really hard on training an AI to do a very specific thing, it could become superhuman at that thing. That does not say anything about its ability to do anything else, right? So for example, AlphaGo is superhuman at Go. It can't play chess. Right? If you train the same algorithm on chess, it'll be superhuman at chess, but it can't play Go. If you train a model on generally talking and text and whatever, like, cool, we get ChatGPT and it tricks us. It passes the Turing test and it tricks us into thinking as general intelligence. It's actually just good at predicting what a human might say in that circumstance, right? Currently, the money's flowing into code. So these models are getting really good at code. And it's awesome and it's super useful, right? But I mean, you still need a software engineer to drive the model, right? Like it's not like, I have 35 people at my company. They're all software engineers. We're hiring more. If you want to work on this problem, we're hiring, right? Despite access to all the tools. Now, I think we are much further behind in hardware, right? Like where Claude Code, you can ask it to make a basic website or make a video game and it does a pretty good job. You should not have that same expectation of Claude Code for circuit boards, nor of these specialized models like us or anybody else for circuit boards. The reality is like, I don't know how many tens of billions of dollars have gone into training for code. Nothing like that has gone into hardware. And it's also arguably maybe even a harder problem because you can't self-verify as easily inside the computer. So point number one is that any intuition you have about how good AI is truly only relevant in predicting what a human might say in text and in writing code. It is not so relevant in other domains yet, right? The second point I'll make is I think you've already named exactly what I think Quilter is and what I think Quilter will be for a very long time. It's a tool. Right? Like it is nothing more than a tool that you use in certain circumstances. It helps you go faster on some things and it can't do other things. And you as a designer choose to use that tool or not to solve your problem. Right? So I think that the role of the designer still remains the same. Right? Like it remains to understand what is the problem we're solving? Why am I being asked to do this board? Are we solving the right problem for the right customer? Are we using the right parts? Are we using the right footprints? How should we approach this? What are the different trade-offs? I think all of those things are going to remain. You're just going to get answers to those questions a lot more quickly than you used to.
I see it being something else that's really useful for a lot of designers and a lot of companies in general, which I like to call a capability enhancer. It may allow you to do different types of designs where you're just not as specialized. And if a company needs to do that design, they can't find the talent, here's something that can probably help you along. Yeah,
I mean, I'll echo that, right? Like for Quilter in particular, probably the majority of our customers to date are actually not professional full-time PCB designers, right? It actually tends to be more the people who are, I mean, frankly, like myself when I was at SpaceX, right? At SpaceX, I was primarily a radiation effects engineer who understood the physics of how particles hit electronic parts and what it's going to mean for the whole rocket. Not a professional PCB designer through and through, but I needed a lot of circuit boards. I needed to make a lot of circuit boards. My circuit boards were not, the ones I designed did not fly. They were test boards that I put into a beam that I'd give to, automation equipment so that we can test more quickly, so on and so forth. So a lot of our customers at this point are actually schematics designers, even firmware engineers, mechatronics engineers, robotics folks who can read and write schematics very comfortably, can poke their way around a CAD tool, but with a lot of struggle, and just get a really big lift and going faster with kind of using Quilter in the loop. They're still responsible for the layout. They still get their hands in the CAD system. They still tweak everything and make sure that it works, but they go a lot faster. Right. And I think that the PCB designers we work with kind of see it that same way.
Yeah, this is interesting too, because I've mentioned on the show before that I've talked to folks at investment firms and VCs, and there's been a lot of obviously interest in this space from that crowd of people, and not one of them has mentioned how AI could potentially increase the size of the market for PCB tools generally, and you just outlined how it can actually do that.
Yeah, 100%. I think this is, so to speak, called the Jevons paradox, right? That you tend to think that when you create a tool, that it will then kind of like drive the cost of that task down to zero, that labor will start to happen in that tool, and so on and so forth, right? Whereas what actually happens is as you make something more accessible, a lot more people swarm in to do it, and overall the market grows. And this has been observed in quite a lot of different markets, getting up until this point. And I firmly believe that's what's going to happen here, right? Like just my own anecdotal experience at SpaceX was that there's at least 10 times as many people who know how to read and write circuit schematics as there are people who can really design boards, at least, right? And all of them would like to, but they have to get help at this moment, right? I think that this really is going to be something that just makes it that much easier for everybody to get their involved in hardware.
So in summary, it's a somewhat of a role changer, somewhat of a capability enhancer, overall probably growing the number of designers, but you certainly don't see people losing their jobs en masse simply because a company decided to add Quilter to their arsenal.
I've spoken to, a lot of enterprises now, from the biggest to the medium sized to the smallest ones. I've never spoken to one that thinks they have enough PCB designers or electrical engineers. Like, we know that that's a problem in this industry. I've never spoken to one that even brought Quilter on and started using it and didn't still want to hire more. There's just nothing I see in the next decade that could shift that. Like, I think the demand for what we do is so high that what you actually want is PCB designers, each of whom are now 10 times faster and 10 times more precise than they used to be, and even more of them to just iterate more, build more, because we just need that much more hardware now, right?
One thing that's interesting about this is, you're one of the few AI company CEOs I've talked to that has, I wouldn't say low expectations of AI, but maybe realistic expectations. Whereas like if I go out on LinkedIn and, I've seen some of these folks even trying to, start a hardware, AI hardware company, and you see what they post and what they talk about. And it's like, they have these ridiculous expectations for what their tool can or should do. It's like, we're going to, code up Starship in an afternoon from a 1-sentence prompt, which, you can't even get ChatGPT to write, a basic article about something and have it be convincing with a 1-sentence prompt. So how are you going to, build these complex hardware systems with the same kind of effort? So I feel like, zero effort gives you a zero effort result, frankly. Do you think just in general, with all AI companies that are out there, whether they're in the hardware space, software space, whatever, that people just need to tone down the expectations just a little bit?
In general, I would say yes. I'll give a perspective on other founders. Being a founder, I kind of have to sympathize with other founders, right? I think that when you...
Sorry, if I could right there, I also do sympathize because like I people know me. I regularly engage in attention-seeking behavior on social media. They're essentially doing the same thing. So I am sympathetic to it.
Yeah. I think there's, especially when you're just starting, it behooves you to build a long-term vision. And when you do that, you find people who also believe in that vision. If you don't do that well, then everybody hates your vision and then you're on your own. That's tough. But there is a tricky balance to thread there, right? With Quilter and the way that we kind of think about it, the way we approach it is, I think that we have not only a vision for what AI might do in the long term, but also a vision for how to get there. And we attract the kind of people who are thinking kind of very carefully about what's actually like a real believable way that like we might step our way towards that. And of course, that's grounded in pragmatism. That's grounded in the tools we have available to us today. And it attracts a great team and attracts great customers, right? Like by being pragmatic about where it's at, I can't tell you the number of times we get off a customer call and the customer will say like, man, you guys are a breath of fresh air. Like after reading all this slop everywhere, like just talking to somebody who says, no, we can't do that is like news to me. And we win deals because of it. People will work with us, even though we're not ready for their boards, to just help us invest in building the right things to finally get there to their boards, right? And that goes a long way.
Honesty really is, I guess, the best policy, right? So yeah, I can understand why people would have that reaction and say, it's a breath of fresh air, especially if you're perfectly willing to say, yeah, if you try to do this, it's the output might be kind of trash,
Yep.
So I think one of the things that often gets mocked on social media with AI circuit boards is kind of silly outcomes that a human would never do. But I had an epiphany about this recently. I kind of had the eureka moment. And for the folks that watch the Altium Academy channel, they'll know that, we recently did an AI versus human video. And I had no idea that the tool that was used was Quilter. I didn't find out till after the fact. So now I kind of had some egg on my face there, but,
That's good.
But the process used to create the AI board was to basically just like throw the one sentence prompt equivalent at the board and see, what is the limit of what can be done. And my realization was that, what really matters here is the process. The model could be kind of not so great. It doesn't probably have to be the best model, but if you don't implement a process around this, then you're not going to get a meaningful result. And then I also realized that, let's say I had a junior engineer working for me and I wanted them to lay out a board. Would I just give them a one sentence instruction and expect them to give me this awesome board that's totally free of problems? And I realized, well, of course not. I would give them an entire slide deck and, PDF file, 10, 20 pages, maybe in some cases, with guidance, specifications, objectives, all this kind of stuff. And I realized we probably have to do the same thing with these AI tools if we really want them to get a result that we can sell to customers.
Yeah, that's 100% correct. Like, the only way that Quilter for sure, but frankly, the way I think that any of these models should know if the design is right, is to be able to compute whether the design is right. Right. So let me unpack that a little bit. Right. Like one of my core beliefs that maybe isn't kind of trivial to agree with, but I hold very dearly is that whether or not a layout is good is a computable question. Right. I'm not saying it's easy to compute. I'm not even saying most of us do bother with the computations, but it is computable. Right. So the kind of the very, very, very high level of how I see Quilter should operate over time is ideally it would understand your entire schematic well enough to know what waveform you should expect on every pin of your board. Right, like what waveform is coming out on your source pin for power, and what you expect as the requirement on your sink. Right, and like all the properties of that, and the board itself is the channel in between. And with that channel in between come all sorts of imperfections, right? There come impedance mismatches and crosstalk and heating and everything under the sun, right? And the question is the choices you made in the layout, did they degrade that signal sufficiently that it still works or sufficiently that it now doesn't? Right? And that hypothetically speaking, if you could really enumerate that, every single concern of every single waveform coming out of every pin, every single requirement of every pin coming in, every single set of quadratic crosstalks, all throughout the whole board, you can compute a list of all of those, identify them against thresholds, and give a thumbs up or a thumbs down. Like this thing will power up and meet our thresholds or not. Right? Easier said than done, but that is a core belief. Now, from that core belief, it dictates how we operate, and therefore how I hate to use the word prompt, but like prompt works, because it's really not a prompt, right? What it means is that if Quilter's not doing the right calculations, it's not solving for the right thing, right? So the first thing that happens when you upload a board to us is we ask you a whole bunch of questions about like, tell us about the currents on your board. We'll attempt to automatically detect that like 5 volts has an amp on it or whatever, but maybe we got that wrong. Please tell us. Tell us it's 2 amps. Tell us it's not 1 amp, right? We try to identify bypass capacitors as an example, right? And we try to identify them automatically. The simple heuristic we use actually that's pretty effective is if you draw in your schematic an explicit line between the pin you're bypassing and that cap, then it's probably a bypass cap for that pin. Now, of course, somebody else is going to have a tank of bypass caps on a different sheet that's just on the 5-volt net, and they know where they meant each cap to go, but like we don't, right? So we'll take a guess, but we could be wrong. And in that process, we're effectively constructing hundreds of different constraints that we then try to meet. So step 1 for the user is to understand whether or not we have correctly understood all of their constraints. That's kind of the first place where we do a prompt or an input. Now, the thing that happens after that is we try to solve them. And it's possible that we knew about the constraints and we just didn't solve them correctly, right? Mea culpa, the model should be better. And that's where the iteration begins, right? That's where designers face the practicality of where these tools really are today, what they're capable of solving and not, and they start to hint and they start to help. For example, you can take Quilter's first placement output and say, well, that wasn't quite right. But you know what? It's actually quicker for me to adjust a couple of these cap locations, adjust where this inductor is, and throw it back in than having done all that from scratch. But you've helped us meet the constraints. Same thing on routing, and so on and so on and so forth.
So in terms of, let's say for Altium users out there, because I know there are a lot that are listening right now, what are the mechanisms that actually allow you to do all of that? Because, I've often thought about what the UI should be to kind of control some of the things that you're talking about. So let's just take placement, for example, right? Like, I kind of wish there was like a way to draw a box around like different parts of a schematic sheet and just define like proximity. Like, these things need to go together, right? That's usually how we approach different, circuit blocks that are going to go into a circuit board. So how do you guys do it inside of an Altium file?
Yeah, sure. So we try very hard to kind of follow the concepts that Altium already has for Altium users, right? And the idea is that like we're not trying to change how you work in your CAD tool, right? So for that specific case of placement, right? So the first rule that I'll explain for the viewers is that in general, anything that you've placed on the board, we treat as a constraint. Anything that is off the board, we place. So already you have a choice of like, do I upload a board where literally nothing is placed and the board is blank? By the way, that's a bad idea. Do I upload a board where everything is placed? Sure, then we can just route for you. Or do I do something in between? And what that in between is, you should use your judgment based on the kind of board you're doing, right? Now, the next level is groupings, like you said, right? We heavily rely on Altium's rooms feature, right? So you can draw physically a polygon that represents a room somewhere on the board, and that's our cue to say all the components that belong to that room shall go into that room. You can also keep a room off the board, and any components assigned to that room will know that, hey, they're all part of the same subcircuit, keep them close. And how do you do that in the schematic?
Sorry to jump in, but not necessarily in a specific place on the board when you have a room off the board, right? It just says these things go together, but they could kind of go together anywhere.
Exactly right. So that's an example of something you do there. And I think in the video that you showed, that's what that was, right? I think you were confused about like, why are there rooms off the board? Like, this makes no sense. Yeah. So I think that's what was happening, is that user did place rooms off the board. And it did sort of like tell Quilter to clump all of the different components roughly together. And so that's kind of why they were proximal. But of course, there's still tweaks you need to make after that, right? And just to come back to your first point of like, how do I do that from schematic? Altium has a really wonderful feature called blankets, where you can draw a blanket around a subcircuit, give it a class name, that creates a room, and it flows really nicely into the rest of the Quilter workflow.
Very cool. So this is another thing that I think is really interesting, where you're giving folks the ability to control the process rather than feeding into the unrealistic expectations that we have around AI, where people just expect to just like upload a board and it gives you perfectly placed and routed and you don't have to do anything.
Yeah, and I'll tell you why, right? Like, Look, at the end of the day, like I started the company because I was designing these boards with SpaceX and we had a problem, right? And, there's many things that Elon is known for, but one thing that everybody will agree is speed is important. And you do not want to be somebody who's in Elon's critical path, right? And so for us, the kind of motivation to get boards done quickly was high, right? And so everything we do is just centered around that motivation, right? Like if you're a team who just needs to get boards done faster, like that's who we work with. Now, realistically, when we go to enterprises and we talk with their VPs of engineering or CTOs or people who are kind of tasked with increasing the throughput of their designs, they're not asking us for like a magic box that spits out a perfect board, right? At that level, nobody expects that. Their targets are like, hey, this layout was going to take me 3 weeks. Can we compress it to 2? That's a win. That's a massive win. Right? Like that's a huge amount of schedule you've cut. Can you compress it from 3 weeks to 1? Oh my God. It's magic, right? So everything we do is centered around how do we take that kind of 2 week, 3 week, 4 week design and compress it to a week? Not how do we take this 4-hour design and make it perfect for mass manufacturing, right? And I think that's where the mismatch comes from. And it's ironic, but that goal that our enterprise customers have set for us is actually much more achievable. It's actually easier to take a really complex board and compress it by a factor of 2, 3, 4x than it is to take a simple board and nail it perfectly, like the way that a truly experienced designer would nail it.
Yeah, that makes a lot of sense. And I'm now kind of thinking about it in terms of the process of like a senior engineer who's defining constraints and objectives, handing something off to a junior engineer who might normally just sit there and place parts or create components all day. And you're essentially doing that same handoff process, right? You're acting as the senior person, the team lead, and just now instead of giving it to a junior person, you're just giving it to an AI that can get it done however fast.
I think that the junior engineer analogy to Quilter, I think, is a perfect one. Like, I think that's exactly how we want to view Quilter. And in fact, I'll take that one step further. Internally, when we think about what the product should look like, when I work with my software engineers, a lot of what I talk about is like what actually happens between a senior engineer and a junior engineer, right? Like taking from my experience at SpaceX, this also happens between an EE and a PCB layout person, right? What happens is, okay, I've completed my schematic. You give it to the junior engineer. You let them work for a day. Then you come over to their desk and you see how far they've got and you point your finger at the screen and you say, oh, like that should be there. That should be there. That's silly. Rotate that. Why did you do this? You should do it this way. And so our inspiration for how this interaction should work mimics the idea of a senior engineer pointing at the screen and saying, nope, 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 like do this, do that, do this, do that.
Yeah. Now I can see where you're getting that, acceleration, because instead of having to wait, a day or two for the junior person to get it done, you wait an hour or two for the placement engine to get it done. And then you just iterate, change some things that you need to change. If you're the senior person, focus your attention on what needs to be focused on, and then you can go off and do other stuff that's equally important.
Yeah, I'll tell you a little anecdote about this that I love. One of our more recent customers is from an aerospace company, and it was specifically a kind of a senior principal level engineer who's focused on the schematic and typically works with a junior engineer for layout. And he took this even a little bit further. So in the span of 2 days, he did something like 28 or 30 iterations with Quilter, which we were like, that's interesting. How did you do that? Like that's like more than we expect. That's more runs and resubmissions on the same board that we typically see. And what he said was fascinating. He said, well, I'm a senior engineer. I'm in meetings all the time. So what I get to do is at the end of my 55-minute meeting, I have a 5-minute break. I come back to my computer. I change a few things on my Quilter input from the results that I saw, and I submit it, and I go to my next meeting. And 55 minutes later, between my next meeting, I see what you guys did, I freeze what I liked, and I tweak what I didn't like, and I resubmit. And in this way, over the span of 2 days, just doing an iteration for 5 minutes every hour, he got to a board where he was like, you know what, that's pretty close. Took 2 or 3 hours to finish up that board and was done with it. Otherwise, he would have waited a week to get that board done before he could even have a few days to focus on it. So right. I think this idea of a senior engineer between meetings, standing over the shoulder of a junior engineer and saying like, move that, change this, rotate that, go, I'll come back. Coming back in an hour, reviewing and doing it again, it worked really well for him. And I think it's going to work well for a lot of people.
And this is where I like to kind of make the point that it's giving you some time back to focus on the really mission critical things that could totally derail a project.
Yeah. The number one thing, like this kind of Jevons paradox, right? Like, why are we going to need more boards if we suddenly can create more of them, right? One of the things we hear more often than not, we ask people, what would you do, right? Like, if you had more time or if you had more throughput on boards, like, what would that result in for you and your business? The most common answer we get is we would test more.
Yeah, I can see that. And actually, that's a really good risk reducer, because if you have more time to test in your schedule, you don't have a risk of a prototype run going bad. You don't have a risk of having to do a respin or maybe failing pre-compliance or whatever on down the list.
Exactly. So that's where I think some of that like inflation of the whole market is going to come from.
Interesting. Okay, very cool. So we're getting up here on time. I do want to say that we're going to have you on for a video coming up soon. It's going to be a pretty cool concept, and folks will get to see the tool in action. So anyone who's out there listening on audio, head over to YouTube, hit the subscribe button, and you'll get notified when that comes out. If you're already watching on YouTube, make sure to hit the subscribe button. So we're going to start to wrap it up. But I guess for my last question for you, Sergiy, is what is on the roadmap for Quilter in the future?
Yeah, so the way I think about this, like last year in 2025, we kind of made one big goal that we drove towards that consumed almost everything that the entire engineering team did. That goal was to build this. So this was the most complex board we'd ever done with Quilter. This is actually two boards, a SOM and a baseboard for an NXP IMX8. And the basic goal was like, let's build a board that can run Linux and like take a video call and like, run Chrome, connect to the internet, have Wi-Fi, all those things. And we pulled that off on this board. That said, that was more a proof of concept than a product, right? Like that was hard. We have a detailed blog that you guys are welcome to read about how this went. Like, you need a very experienced engineer to drive Quilter, to fix all of its mistakes, to do these iterations. A solid man week of work still went into making both of these boards, right? So, like, it's not like we fully automated it. But it was really about demonstrating that we have a good enough solver to tackle problems of that scale. Our entire theme for this year is to make this actually a product. Right? Like, how do we enable our customers to do boards of this complexity and enjoy the process and like actually understand Quilter and not have it explode in your face, be able to give it all the right kinds of constraints. So things that we learned from this that are coming really soon, right? On this board, we had to manually do a fan out for the BGAs on here. We're about to ship BGA fan out into the product, right? So it'll take care of that for you. For this board, we developed polygon pores. So there's a whole bunch of power on here that's done with polygons. There's still things we're trying to improve about that. That's about to ship. The biggest thing was actually constraints. And this is our number one enterprise request, is this entire board was done with a single clearance value for all things, right? So that like awesome Altium matrix of like trace to trace, trace to via, via to pin, blah, 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 one number, which is not good enough for any serious enterprise, to say the least. So that's something
that's
big.
If it's big enough, it's good enough. But once it gets too big, it's not useful anymore.
Or if you pay your fab enough.
There you go. Yeah.
But realistically speaking, right? Like, we have to accommodate that. So that's about to ship. We just shipped support for impedance calculations within Quilter, right? So you can now tell us that it's 50 ohm single-ended or 85 ohm differential pair. We'll compute the right geometries based on your stack up to have that accounted for. We're going to ship blind and buried vias hopefully in a few months, which is we didn't need for this board, but we will need for other boards of this type. So everything is around how to give you, the designer, the control to actually get this board to the level of quality you would expect, right? And that's much harder than just making this board and proving that it works.
And so anyone who's interested in reading that blog, make sure to head over to YouTube, look in the video description, and we'll have a link there where you can access it. Last question about this board. Is there anything that you wish the system would have done differently?
Almost everything. I mean, come on, right? Like, so we published all the raw Altium files for the inputs and the outputs for everything on this board. I welcome people to take a look at Quilter's raw output and like have some laughs, right? There's a lot of dumb things on there, right? So is there anything I wish it could have been done differently? A lot. a lot, right? Like there's,
but you iterate through it, right? You target the spots that are the most critical.
Yep.
You say fix this first, and then go on down the line, and eventually it gets good.
Yeah, I mean, I would still say that even with human in the loop, the result we got to would not be one you want for a production of this board at the million scale. Nowhere close to it, right?
Okay.
Like I think the result is good enough for the board to work. It's good enough for an initial test of the schematic. It's good enough to give to your firmware engineers. It's good enough to get some validation on your system. But would I take that production run in the millions? Absolutely not.
Sure.
Right? At the end of the day, the thing is that like what we're solving is a problem people have been trying to solve for 60 years. Like the first papers on automated placement and routing date back to the early 60s. Right? So it is a very hard problem, and we're going to be solving it for a long time. We've raised a whole lot of money to do it. We're going to raise a whole bunch more money to do it. We've hired 35 of some of the smartest people I've ever worked with in my life to work on it. We're going to hire a lot more of them. And we're going to keep hammering at this for decades to come until we actually really, truly solve this, right? And that's what I say when I mean there's almost everything that I wish we could do better on it.
Well, as you continue to make progress towards actually solving this age-old problem, of course, we'll have you back on to talk about it. And I hope everyone will subscribe to the channel. They'll be able to see that upcoming video that we're going to do together, looking at all the capabilities in Quilter and having some fun with it. So that'll be great. Sergiy, I want to thank you so much for being here today. Long overdue, in my opinion. But I'm glad we finally got to it.
Absolutely. Thank you so much.
Absolutely. To everyone that's out there listening, we've been talking with Sergiy Nesterenko, founder and CEO of Quilter. If you're watching on YouTube, make sure to hit the like button, hit the subscribe button. You'll be able to keep up with all of our podcast episodes and tutorials as they come out. And last but not least, don't stop learning, stay on track, and we'll see you next time. Thanks, everybody.